All right, everybody, it's Hugo Bown-Anderson and Eddie Mattia from Metaflow and Out of Bounds here. What's up, Eddie?
Not much, Hugo. How you doing?
I'm well. I'm actually incredibly excited to be teaching this or introducing this YouTube tutorial with you, this video tutorial. Today, we're actually going to be talking about LLMs and Gen AI in practice. So a guide to recent techniques and trends at Out of Bounds and Metaflow. Everybody, we work a lot in machine learning infrastructure, so building tools that help data scientists, MLEs, anyone working in, so that's machine learning engineers, anyone working in the data space to do the modeling they love while having access to the infrastructure that they need. And a big part of that we're working on currently are LLMs and thinking about how to embed LLMs, foundation models, generative AI more generally in your pre-existing enterprise stacks, and moving from all the prototypes we see to actually having your foundation models in your pre-existing production systems. So we've been working on this stuff and we wanted to bring a bunch of it to you. So what we're going to do today is we're going to teach you about methods for working with LLMs. These stories are going to be guided by examples you can run on your laptop in our Metaflow sandbox. So that's a free hosted cloud environment provided to all of you. You can think of it as Google Colab for MLOps, if you will, but it's a lot more than that as well. We provide you the full stack of infrastructure, essentially, to play around with these things. As developers, you'll expand your awareness of how researchers and product designers are working with LLMs, with an emphasis on connecting high-level concepts such as fine-tuning foundation models and vector databases to the fundamental math and APIs data scientists should understand. I also think business-minded executives will get a bunch out of this, and you can get hands-on or follow the high-level stories to deepen your sense of what's possible with LLMs. I think the primary value of this workshop will be as a guide to help teams set reasonable goals in the complex and fast-moving world of large language models and understand what you need to successfully support your team's next LLM projects. Prerequisites are a basic knowledge of Python, ability to use the command line, and ability to use common machine learning algorithms in a notebook environment. But if you don't know those things and you have a willingness to learn and a curiosity, we always think that that's the most important prerequisite. Before we jump in, just a bit more about what you'll learn. There are lots of different ways to build on top of LLMs. There are, in the short term, cheap ways, such as using APIs. There are short-term, more expensive ways, such as fine-tuning and training your own. The methods you choose will have significant consequences in the software you can build and how your dev team works. We're going to learn to think about about these choices as we develop basic apps you can use as templates for future Gen AI projects. And as we said before, you'll have the option to follow along in our provided sandbox dev environment, where we'll unpack these choices and make the trade-offs and decision space concrete. Before jumping in, Eddie, is there anything you'd add to that? That was a lot to take in, everyone, but of course, over the next hour or two, we're going to, see this play out. Is there anything you'd add to that, Eduardo?
Just to get started, play around and tinker around with the stuff that we're going to show you. A lot of it is, sure, we're talking about enterprise infrastructure and fancy business terminology, but also a lot of it's just kind of messing around with your ChatGPT interface to get it to do what you want. And just understanding how these LLMs behave is probably, that's my advice, in all of this, is that's the most useful skill to make your own knowledge, to focus on your own knowledge and understanding how to use these systems.
Totally. Yeah. Play around, enjoy yourself, have fun, and create, build. So just want to confirm you can see my screen, Eddie?
Yeah, it looks good. I see the title slide right now.
Amazing. This beautiful data scientist reaping the fruits of everyone's work while being supported by a platform and infrastructure engineer down below. Great. So let's jump into thinking about LLMs and generative AI in practice. So just to motivate what we're talking about today, and we'll link to a talk given by our co-founder and CEO, Ville Toulos, at the San Francisco Exploratorium, actually, about these, that goes into more detail in the slides I'm about to present. But we're going to give a classic example of e-commerce. Now, this is one illustrative example. And of course, the types of things we're talking about extend to a lot of different spaces, but we thought to ground it in concreteness. So in 2014, if you were trying to buy a sofa online. You might have seen a website like this, and you'll click on something and go on through to purchase it. And this will probably interact with a database on the back end and execute some sort of SQL query and give you information and a result. And then, based upon that, right? So of course, there's a lot of like data engineering and then front end stuff that goes into this. Well, that's the basics of what would have happened 9 years ago. So what's happening now? What's happening differently there, Eddie? Now, do you think?
Oh, the pictures are definitely bigger for one.
Exactly.
Like different color schemes, you can kind of see things going from dark to light, like a lot of focus on design, aesthetics. Sure, lots of like fancy UI, UX research has gone into this.
Absolutely. But not a lot necessarily on the back end yet, right?
Yeah, but yeah, good point. It's still kind of like a grid of images that like you can see how this is pretty clearly connected to like that SQL way of storing your data backend system.
Exactly. But we do have maybe some sort of chatbot down here or customer service, so we have the beginnings of something along those lines. So the question then is, with all the generative AI stuff, how is this going to change? And so in the not too distant future, we're going to have a lot of different capabilities due to this, right? So now, what we're going to see soon is some sort of natural language interface which can interact with everything that's happened there. So I'm seeing a big room with a bunch of stuff I may like, but let's say I actually wanted a pink sofa instead. So I'd type that in, and then I'm actually going to see a pink sofa appear there, right? But let's say pink's cool, but let's say I actually wanted to try leather immediately and see what that looked like in real time. Then we'll have something along these lines. But of course, as we'll get to, the Gen AI isn't that good because it's like the 6 fingers on humans or whatever. We've got like these pillows in the background there, right? But that, all jokes aside, this is quite incredible. Let's say I wanted to find out more about this lamp. Then I'll get information about this lamp, perhaps some sort of influencer recommendation there. And so let's just unpack everything we've seen and happened there, because that looked maybe relatively straightforward, but there's actually in this not so distant future, there's a lot happening here. When I type something in there, I'm performing some sort of query with a large language model, right? Then when I clicked on this, there's an object recognizer and some sort of LLM creating a description there, then an influencer recommendation system. We've got image generation happening as well. And I made kind of a joke or a teasing aside around how, image generation doesn't quite get things right all the time, but it did a very good job in this case. And we also have personalized discovery, right? So what it's doing is making these types of interfaces essentially easier to use and more human-centric and more human-friendly. Is there anything you'd add to that, Eddie, before we move on?
Yeah, I think in addition to the human friendliness, like the generative word is like obviously becoming a buzzword, but it's so apt in this example of what the future might look like. With this couch that we're seeing here, unlike the SQL database grid of the website, this couch might not exist or might never have been produced before by any manufacturer. So that like somehow through the connection of like text to image generation, we're actually creating like a new real product that a company could get a signal if people are looking to buy. Now there's like obviously a question where like at some point that becomes like bad business to just like promise things you can't actually make and can't actually deliver on. But I think that that's a superpower for like actually figuring out what people want, doing personalized discovery, as you mentioned, and then even connecting it all the way down to these downstream things like detecting images within that or detecting objects within that generated image and having an influencer recommendation appear associated with that object.
Yeah, absolutely. And then on top of that, as I said, this was an illustrative example, but like this will impact all types of things such as inventory forecasts, logistics, lifetime value optimization, causal marketing models, that type of stuff. So suddenly we've got all these things that we're including in our software now. And the question now is, wait a second, we have existing software stacks. How do we incorporate this type of stuff? And there's a lot of talk around prototype to production in the world currently. Not a lot of it is telling us much about prototype to production as far as I can tell. So we really want to attack that head on. And so the question is how does this interact with the pre-existing stack, with all the data engineering challenges, all the data lakes, data warehouses, having things in Parquet shards, being on S3, in Snowflake, these types of things? How does this interact with the compute layer? If you're sending things to GPUs and you need CUDA drivers, or sending things to cloud resources on AWS, Azure, or GCP, how does this interact with your orchestration tools when you have complex workflows? Perhaps you have your data engineering workflows orchestrated with Airflow. Perhaps your machine learning workflows are orchestrated with Metaflow, which of course integrate with each other. How do you integrate all of these new things into your orchestration tools? How do you think about versioning here, right? How does that correspond with the experiment trackers you use? What changes with the deployment story here? And then how can we leverage this entire stack and have data scientists and machine learning engineers focus on the models that they love to build? So these are the types of questions that we're going to dive into today, or give a sense towards, and we'll provide further resources with respect to all the things you can look at in Metaflow that will help you think through this. So all of this really motivates why we even want to use something like Metaflow. So Metaflow, which was originally developed at Netflix in 2017 and open sourced in 2019, allows you to build systems and machine learning and AI systems, and not just models. So as I've really stated already, is Metaflow allows you to interact with this entire stack as a data scientist or machine learning engineer while focusing on the top, on the modeling. And there's often a question, wait, why is data at the bottom of the stack? Don't data scientists really care about data? And yes, of course they do. They aren't necessarily so concerned with data in the infrastructural layer and in the infrastructural sense, in terms of all the data engineering that comes into play. Data scientists aren't too concerned about whether their data comes from Snowflake or a different place or an S3 file. They want to start an S3 bucket. They want to start working with their data and modeling it as soon as possible. So then how does this stack interoperate with LLMs and foundation models? I mean, one way to think about it is we have, and this is once again an illustrative example, but particularly in your organizations, you want to start thinking about where your governance boundary is, what you control and what you don't, essentially, in terms of the tools and models you use. If you have chatbots or products which require recommendation or whatever it may be, the example we just gave, you may have an open source foundation model which you don't govern, but then you bring it in and you fine tune it, you use it for embeddings and serve the results of these to a customer service chatbot. You may also have data coming from a data warehouse. These, along with the embeddings, going to personalize recommendations, then back into a warehouse, which are then used for your product. Similarly, you may have AI vendor APIs, which generate images. They get information from your data warehouse, then put them to cloud storage, and then they're directed into your product as well. So this is to give kind of one sense of the way things can work, but also to get you already thinking about the importance of your governance boundary, and also thinking through the ability to switch these things in and out. Let's say you're using DALL-E 3 to generate images here, and you decide the new version of Stable Diffusion is actually better for your needs. Ideally, you'd be able to swap these things in and out, and that's something which Metaflow affords as well, relative ease of switching interoperable components. So, as we've already really said, on the data layer, we need secure and fast connections to data warehouses and lakes. We need scalable compute with CPUs and GPUs. We need a dev-friendly API for building systems in the form of an orchestrator. A key part of that is being able to version all code, data, and models automatically. Having access to that version stuff as well. Then being able to deploy, and then being able to get the best models, and kind of closing this iterative loop between working locally in notebooks, for example, do all the basic science and figure out what models you may want to use, and then deploying to production and coming back. So what Metaflow provides is a common API for this robust, battle-hardened infrastructure, and you can see all types of things here. You can use scikit-learn or any Hugging Face models, etc., on the modeling layer. You can deploy with Argo step functions, version with Metaflow, orchestrate with Metaflow. If you're already doing data engineering orchestration with Airflow, as we said, we interoperate with that, and all your data and compute layers of choice. We allow you to plug and play there, and we'll get into examples of those very shortly. On top of that, of course, we can't forget about key foundational operational concerns such as security, observability, and having kind of human-centric dev workflows. So what we're going to do is jump into the sandbox. There are lots of other lessons we have on our sandbox. We've got recommendation system lessons, natural language processing, computer vision, among many others. A great one that Eddie worked on, which is a foundation model, the speech to text, OpenAI's Whisper, right, Eddie?
Yeah, totally good stuff.
And this is a catalog that's growing and growing. So I think is that in the spirit of talk a bit about the structure, and then I've been babbling on for far too long. So then we're gonna get in, and Eddie's gonna start showing us how to do all of this stuff. So part one, the easy way. Eddie, you're going to talk us through hitting large language model APIs, right?
Yep. Yeah. Like using OpenAI in Python code, and kind of like how you can change OpenAI, whether you use ChatGPT UI or whether you want to write your own Python notebooks or scripts that call the same model behind the scenes.
So good, man. And then in part two, tell us what's going to happen there.
In part two, we're going to kind of do the same thing, but we're going to use an open source model. So instead of calling it an API, we're going to actually like have the model itself living on our sandbox and like kind of look at the PyTorch of it all, like actually see what the model is on the computer, but kind of doing the same thing that we were doing in the first part with ChatGPT.
That's so cool, man. And what can you tease us with what the model is? What's the model?
We're going to actually use a whole bunch of them. So we're going to like kind of basically like look at what is Hugging Face really, which is like the distribution channel for most of these models in the open source community right now. So we're going to kind of understand like what basically like what do you want to do like on a task level with Hugging Face, and then how do you go shop for models in the Hugging Face hub and pick one.
Amazing.
So one model we use is Bloom, but there's many of them, and we're going to go through like 3 or 4 of them throughout the workshop.
So cool. And I presume a lot of the viewers here know what Hugging Face is, but another way to put it is it's the wild west of machine learning models at the moment, right? I mean, it's an amazing, crazy space, hey?
Hundreds of thousands of models and data sets and like many different things that you can just go point and click your way into finding.
Totally.
Downloads for many of them. It's really wild.
Oh, pardon me. So we've used our models and that type of stuff, but then wait, what's happening here? We're gonna have a ragathon?
We're gonna ragathon. We'll actually talk a little bit about prompt engineering, just kind of like the basics of what people even mean when they say that word. Like show you how to do it again in the ChatGPT UI, and then same thing in a notebook, and then kind of keep going in that direction of like make the LLM more relevant by giving it better data in how you talk to the LLM. So there's like certain ways that you can kind of like write that ChatGPT will just listen to you better is the idea around all of this. And then of course RAG is like put your own data inside of that way that you write to ChatGPT.
That's so cool, man. And then we're going to productionize as well.
Yeah, so what we're talking about here, this is like the part where Metaflow comes in. So like all of our conversations around like workflows and kind of like more enterprise concerns. If you're going to do something like RAG, it's like one of the biggest reasons to do it is you want fresh data. And Metaflow has features that will help you do things like refresh and index, which if you're not familiar with that terminology, we'll go into that in the RAG sections. Basically, the idea is like you'll get to deploy in your sandbox workflows that run on a schedule or when events happen in your cloud systems. And then something happens, it updates the pipeline that is what's feeding the LLM interactions that might be facing your end users, or might just be you talking in a notebook.
Super cool, man. And then to wrap up, we'll be fine tuning, right?
Yeah, so time permitting, maybe we'll do this in another lesson, we'll see, but we can at least walk through the code of like what is it like to actually now take one of these models that's open source, Llama 2 in this example from Meta AI, and then actually train it ourselves. So unlike RAG, where we're just kind of changing the input output that the model sees, we're actually here going to be taking the model itself, a 7 billion parameter Llama 2 model, and we're going to be training it, and specifically using a bunch of like kind of fancy optimization techniques called QLoRa, that have become trendy lately for people who are doing this in resource constrained environments. So yeah, the upshot here is we're like taking our own model, like we own the weights in this open source paradigm, and then we're gonna like see a little bit how to do that process of fine tuning and then serving the model ourselves. So this is much more like if we wanted to have an API, like the thing that we're using in these first lessons with ChatGPT in our notebook, but we actually want to own the whole supply chain is the idea there.
Amazing.